Find the exact value of arcsecant of the square root of 2. Well, the arcsecant of the square root of 2, that's an angle, some angle theta. So we can think of it as secant of the angle is equal to the square root of 2. And secant, actually, we can say, well, this is 1 over cosine. 1 over cosine. And then we can actually just find cosine here. So if I multiply both sides by cosine, and then divide by the square root of 2, I have cosine of theta equals the 1 over square root of 2. Now, this never shows up on the unit circle, but on the unit circle, everything's rationalized. So if we multiply by root 2 over root 2, we get root 2 over 2. And that certainly does show up on the unit circle, right? So we have a circle, and when cosine is square root of 2 over 2, well, that happens here at pi over 4 and at 7 pi over 4. Now, we're looking at, this was for cosine, but of course we're looking at the original secant, arcsecant. And arcsecant, the restriction on that is pretty much the same as the arc cosine, in that it's only going to give us something in the first 2 quadrants. And so we're only allowed angles that are these angles here. I cut out pi over 2 because secant of pi over 2 is not even defined, but everything else over here is. So we can't use the 7 pi over 4, but pi over 4 we can. And so pi over 4 is going to be the solution here.